So we just found a confidence interval for the mean waiting time of customers at the restaurant. But you may want to take this analysis a step further, as perhaps the mean waiting time doesn't tell the whole story. Perhaps you, as the industrial engineer, are interested in analyzing customer experiences that may take a little longer than desired. Let's say an industry standard for waiting time is 2.5 minutes, or 150 seconds. What is the 99% confidence interval for the proportion of customers who wait longer than 150 seconds? Okay, this could be something of interest to us. What's the proportion of people that come into our restaurant and wait longer than the industry standard? That's very different than the mean, okay? But it's also very useful for us to understand that kind of thing. So how do we figure this out? This is a proportion problem, a confidence interval for proportions. We can use the COUNTIF function in Excel to help us out with this. Okay, the COUNTIF function in Excel. Okay, so what do we need for the COUNTIF function? That requires two different inputs. Okay, let's just rewrite this. The COUNTIF function requires two things. One, the range. Okay, that would just be the cells. We're going to highlight the cells that we want to count. Okay, and the if part of the count requires a criteria. In this case, it would be longer than 150 seconds. Okay, so what we're going to do is we're going to go to the customers, okay, and we're going to count the waiting times that were longer than 150 seconds. Okay, so how many of those 200 waited longer than 150 seconds? That's what this COUNTIF statement is going to return to us. Okay, it's another important function in Excel. The count function just counts up the number of observations in a particular range. The COUNTIF function counts up the number of observations in a particular range that meets some criteria. Okay, and they've got a weird way of writing that criteria. You should really look at the Excel help function to figure out exactly how this should be written. But in this case, it's written with quotation marks around it. Okay. So now we know that we want a 99% confidence interval, so alpha is 0.01, okay? And we know that the sample size is 200. And we know how many customers wait longer than 150 seconds based on this COUNTIF function, okay? That's 69. So 69 customers out of the 200 waited longer than 150 seconds, 2.5 minutes, or this industry standard that we calculated. Okay, based on that, we know that p hat is 69 out of 200, or 0.345. Okay, so our point estimate for the proportion of customers waiting longer than 150 seconds is 0.345. Out of our sample of 200, 34.5% waited longer than 150 seconds. Okay? This is a confidence interval for proportions, so we're going to use a z value in the calculation of confidence in the confidence interval. And we want alpha over 2 in the tail. That is 0.005. Okay? We can go look up in the table the intersection value associated with 0.995, okay, and find out what the row value is and the column value is. If we do that, we've got 2.5 in the row and 0.07 in the column. Okay, so our z value is 2.57. Another way to do this is with Excel. Again, you're on a desert island. As it turns out, you don't have your textbook, but you do have a laptop and a power source, and you have Excel. Could happen, okay? So you can go and use the norm s inverse function in Excel. What is this? The standard normal, norm s. It's backwards, but that's the way they did it. Standard normal inverse function, okay? And what you have to read in is the cumulative probability. Cumulative probability. Okay, that's the probability from the lower bound up into some value. Okay? So if you wanted 0.025 in the upper tail, okay, you would need to read in a cumulative probability from negative infinity up to that value, which would be 0.975. Okay? So if you implement this norm inverse function to find that value right there with 0.025 in the upper tail, you would read in norm S inverse the cumulative probability of 0.975, and you get 2.57. Okay? If you were to just put in 0.025 here, that would be 0.025 in this lower tail, and you would get negative 2.57 in that case. Okay? I encourage you to take a look at the Excel help, figure out this function, figure out what you have to put in and what comes out. Okay? But that's also very useful when implementing some of this stuff and you don't have a z table in front of you. Okay, so now we've got everything that we need to find the confidence interval, the 99% confidence interval. That is p hat plus and minus z alpha over 2 times the square root of p hat 1 minus p hat over n. That is 0.345 plus and minus 2.57 times root 0.345, 1 minus 0.345, all over n, which in this case is 200. And so once we do this calculation, we should get that the lower bound is 0.259 and the upper bound is 0.431. Okay? So what does that say? That says that the 99% confidence interval for the proportion of customers who wait longer than 150 seconds, 2.5 minutes, is between 0.259 and 0.431. Okay? Another way to say that is between around 26% of customers and around between 26% of customers and 43% of customers wait longer than 150 seconds on average with 99% confidence.